So for the answers for this exit ticket, you were asked to use the properties of isosceles and equilateral triangles to find the measure of the indicated angle. So we're looking for angle ACB's measurement here. And you can see we have a 45-degree angle, a couple of congruent sides there. So we do have an isosceles triangle being pictured there. And because of that, I know the two sides are congruent in there. Inside the triangle ADC. So they should both be 45 degrees, which means that the remaining angle is 90 degrees for angle DAC. That's not as important as depending on which rule I want to use, because I could either say that ACB is a linear pair with angle ACD, or I could say it's an exterior angle of triangle ACD, and in either case, either if I'm adding the 90 and the 45-degree angles, or if I'm doing 180 minus 45 degrees, I would conclude an angle ACB is 135 degrees. For the second question, you were asked to find the measurement of angle DBC, and so what you see here is I do have an isosceles triangle which has been cut down the middle. We have rules for that. And there's different ways to approach this. But because of the isosceles triangle here, I do know that angle C is going to be 70 degrees. And I know that angle ADB is going to be 90 degrees as well, which by the, third angle theorem, or by the triangle angle sum theorem, I can figure out that the two angles that I have pictured there are each 20 degrees, and angle DBC is one of them, so it's going to be 20 degrees. And for the last one you were given, you wanted to find the measurement of angle ABC. Now, they have different markings on these two triangles. I mean, these are both isosceles triangles, but they're in no way congruent to each other. And this gets into a topic we're going to talk about later, similarity. The triangles, however, are similar, because I can say that angle E is congruent to angle D because of the isosceles triangle theorem, which means that angle DCE would be 70 degrees by the triangle angle sum theorem. Angle DCE and angle ACB are congruent because they're vertical angles. And I also know, because angle ABC up there is an isosceles triangle with the sides AC and BC being the legs of that isosceles triangle, I know that angle A and angle B have to be congruent to each other as well. So I need two angles that are congruent to each other, have the same measure, and together would add up to the additional 110 degrees I would need to combine with the 70-degree angle, an angle ACB, to total 180 degrees. Well, that's going to be 55 and 55 again. So angle ABC is 55 degrees. So angle ABC and angle DCE have the same measurements for these two triangles, but they're not necessarily the same size. I mean, so they would be what we would eventually we'll talk about later as being similar triangles, but they're not congruent. And that's the end of the exit ticket questions. If you have any further questions, please feel free to contact me or your teacher. Until I see you in my live lesson, or I get to talk to you later, have a good day.